Dear friends, today we are going to discuss about the data science. So, if you see the agenda, evolution of data, introduction to data science careers and salary, statistics for data science, what is machine learning, types of machine learning, and what is deep learning. First, you can see the every day we are going to work with lots of data. So, what is the importance of data? You can understand from this one. So lots of data is evolving every minute to minute, second to second. So how you are going to deal with data? Evolution of data. So the data is every day it is increasing. So almost you can see 3 millions of data in the form of social media networks or newspapers, agencies or any college students, statistics, population statistics, everything is revolving around the data. So what is data science? Let me briefly introduce what is data science. Data science, also known as data-driven science, is an interdisciplinary field about scientific methods, processes, and systems to extract knowledge or insights from data in various forms, either structured or unstructured. So we have different persons involved in the data science. They are called as first one data analyst, second one AI or ML engineer, third one data scientist. So let us see the roles of each and every one. Data analyst takes data and uses it to help companies make better business decisions. So here the data analyst plays a key role in the organizations or companies. What is his role? He is going to be doing better business decisions. Next, data scientist. What is the role of a data scientist? Data scientists are those who crack complex data problems with their strong expertise in certain scientific disciplines. They work with several elements related to mathematics, statistics, computer science, etc. So here the data scientist is going to be working with complex, very difficult data problems. So a data scientist should have a strong expertise in the certain scientific disciplines. So here data scientist is going to work with several elements which are related to mathematics, statistics, computer science, etc. Machine learning engineer. What is the role of a machine learning engineer? Machine learning engineers are sophisticated programmers. They are going to develop machines and systems that can learn and apply knowledge without specific direction. Artificial intelligence is the goal of a machine learning engineer. So now let us see the salary trends for data analyst, scientist, and machine learning engineer. On an average, if you take the Indian salary for a data analyst is around 4 lakhs, 4,660 rupees. For data scientists, the average salary is around 6 lakhs 93,637 rupees. And finally, the average salary for an machine learning engineer is 7 lakhs 19,646 rupees. So here we can see the roadmap for the data science. Here first we need to earn a bachelor's degree. So fine tune technical skills like statistical methods and packages, R programming, Python programming, or SAS languages. Next, you need to have data warehousing and BI knowledge. Should have a preliminary knowledge on data cleaning, visualization, and reporting techniques. And also, you should possess working knowledge of Hadoop and MapReduce and machine learning. And next, to develop business skills. You need to develop analytic problem solving skills, effective communication skills, creative thinking, and industry knowledge. Next, You need to earn master's degree or certifications programs. You should do either MS or MTech in computer science, statistics, machine learning. You should earn big data certifications, data analytics, machine learning certifications. So next, we should have real-time project work, expertise on real-time projects which are related to our field. What are the skills that should be possessed by a data analyst? First one, analytical skills. Second one, communication skills. Third one, critical thinking. Fourth one, attention to detail. Fifth one, mathematical skills. And the last one, technical skills or tools. Next, coming to data scientist, what are the skills that are required for a data scientist? First one, analytics and statistics, machine learning algorithms, problem solving skills, deep learning, business communication, and technical skills or tools. Next, what are the skills required for machine learning engineering? Programming languages, calculus and statistics, signal processing, applied maths, neural networks, and language processing. What are the data science peripherals? First one, statistics. Second one, programming languages. Third one, software. Fourth one, machine learning. And last one, big data. So what is data? You can see the data, qualitative data can be divided into nominal data, ordinal data, and binary data. So what is nominal data? Nominal data consists of, for example, the gender, whether it is male or female. The ordinal data, for example, when you take the customer data, so what is the customer ID and what is the rating that we going to give on the scale. For example, customer ID 101 strongly agree, customer ID 102 disagree, customer ID 103 neutral, customer ID 104 agree, etc. Next, what is binary data? Binary data is nothing but what is the customer ID is whether he is owning a car or whether he is having a car, yes or no, two values. So next, coming to quantitative data, it is divided into discrete data and continuous data. Discrete data is, for example, organization is there. For example, Samsung is there and how many number of products it is going to sell. And for example, Apple is there, how many products, for example, 50 products they are going to sell. Next, Nokia, LG, Sony, etc. Whereas continuous data, the data, for example, if you take the patient details like patient ID and weight of a patient. So, for example, patient ID 32, what is his weight? 86.5 kg, for example. So, continuously it is monitored. That is called continuous data. So, next, variables and research. What are the independent variables and dependent variables? So, when you take a variable, for example, x, let us suppose, is a independent variable. And for example, y is a dependent variable. So, here y is dependent on x. So, here what is the dependency or what is the relationship that exists between x and y that we are going to see here. Next, population and sampling. Population, if you take the entire population, you calculate a sample or we take just a piece of that is called as sample. So here we make use of probability and non-probability techniques. So what is probability? Random sampling, systematic sampling, and stratified sampling. Measures of center. We have mean, median, and mode in the measures of center. Next, measures of spread. We have range, interquartile range, variance, and standard deviation. Next, we have formulas related to this variance and as well as standard deviation. Skewness. So this is one of the important factor in data. So here we first take make use of histograms of different distributions of data values. So here we can see left skewed values, symmetric values, skewed values, and right skewed. So here the distribution graphs which are equivalent to the histogram will be taken, and we are going to make use of whether it is a negative or left skewed, or we can take whether it is a positive or right skewed, or we can take whether it is a symmetrical one. Next, confusion matrix is one of the important measure that we use to calculate the accuracy of our model. So in this confusion matrix, we have actual values and the predicted values. So here again, actual, we divide it into good or bad, as well as predicted, we have good as well as bad. So here you can see what is true positive value and a false negative. So here, when you take the combination of actual versus predicted, good versus good, in this combination we get true positive, whereas good bad, we get false negative. And if you take the actual value, a bad value, and it is bad versus good, false positive, bad versus bad, true negative. So how you can calculate the accuracy of your model with the formula true positives plus true negatives divided by true positives plus true negatives plus false positives plus false negatives. So probability. How you can define probability? Probability is the measure of how likely something will occur. So in this we discuss about probability density function, normal distribution, and central limit theorem. So probability density function is nothing but the equation describing a continuous probability distribution. And next, coming to normal distribution, it is a probability distribution that associates the normal random variable x with a cumulative probability. So here, the normal distribution is defined by the following equation: y is equal to 1 by sigma square into square root of 2 pi into e power minus x minus mu square by 2 pi square. So here where x is a normal random variable, here mu is the mean and standard deviation. Next, the central limit theorem states that the sampling distribution of the mean of any independent random variable will be normal or nearly normal if the sample size is large enough. Next, what is machine learning? Machine learning is a class of algorithms which is data driven. That is, unlike normal algorithms, it is the data that tells what the good answer is. So how you can see the machine learning getting computers to program themselves and also teaching them to make the decisions in a better manner. Where writing software is the bottleneck, let the data do the work. So here machine learning is nothing but we need to make the computers to program themselves, and that programming should be the best one. They should think like humans and they should perform well with better accuracy and precision. What are the features of machine learning? First feature is machine learning uses the data to detect patterns in a data set and adjust program actions accordingly. And what is the second feature of machine learning? It focuses on the development of computer programs that can teach themselves to grow and change when exposed to new data. Next, what is the feature of machine learning is it enables computers to find hidden insights using iterative algorithms without being explicitly programmed. And machine learning is a method of data analysis that automates analytical model building. So how this machine learning works? If you take a traditional programming versus machine learning, you can see in the traditional programming, the data and program are given as input to the computer. Okay, and then it produces the output. Whereas in machine learning, what happens? Data along with output will be taken as the input for the computer, and finally it will create a model. So here it is learning from the data. It is finding the hidden insights. Next, applications of machine learning. Now we can see the first application of machine learning in Google Maps, and also it can be used in face detection, face recognition. Okay, while you Google photos, you can see. And Uber, important application of machine learning is Uber, that is car portal. So if you come to important application of machine learning, it is used in Google Siri, okay, in Amazon Alexa. So you can see in Amazon, when you purchase a product, a customer is going to purchase a product, or he is going to put a product in his cart. Then it also gives you a message that customers who viewed this product also view. Okay, so it's going to give some options. That means this is one of the best application. But why? Because already a customer who is going to be purchasing a product, he might be interested, or most of the customers who bought that product have might have also bought some other products which are related, like accessories. For example, when you buy a mobile, so what are the accessories that you can buy along with it? Maybe earpods, okay, smartwatch, etc. And also the important application is Uber. In Uber, while you book a car, so here when you make use of the source, destination, and the destination, source and destination. So from where you want to travel. So here you can see the different options available. This Wi-Fi. Next, what is the cam and how the GPS is working every day. And also you can find out the train station with the machine learning. And also it can be used in the marketing, that is in the business application, dynamic pricing, demand. And it can also be used in Netflix, Amazon Video, Hulu. Next, what is the market trend? Machine learning. Nowadays, you can see the machine learning is a buzz term, along with big data, data science, and deep learning. So worldwide, if you can see the past 5 years, how this machine learning has been put in the second place after the big data. So if you take the big data is leading the market in the first place, after that machine learning second, after that data science, and finally deep learning. So you can see the life cycle of machine learning. First, collect the data. Collecting the data from different sources, first step. The second step, data wrangling. Data wrangling is nothing but discovering the data, next structuring the data, next cleaning the data, next enriching the data. And step three, you can analyze the data. The data can be analyzed. So which type of data, from where the data has been collected, and what kind of data it is. Like that we can do in the step three. And in the step four, train algorithm. And in the step five, test the algorithm whether it is working. If it is working, what is the accuracy of that model or that algorithm? And finally, deployment. If you see the step one, collecting data. So the data is collected from different sources, no doubt in that. For example, the data may be collected from PDF files or Excel files or YouTube videos or disks or Twitter. So the data is collected from various sources in a server. And coming to the second step, data wrangling. Data is acquired from different sources. So when the data is acquired from different sources, obviously the data will be of different shape, different size, different texture, different color. So here we need to perform the filtering of the data. So the data filtering enables you to make it into uniform shape and all these parameters. And finally, clean the data. And next, step three. What is data analysis? If you analyze the data, it can be given to a model. And next, training algorithm. So here we give a training set to the model. So according to that, the model will be behaving, working, functioning. So here we need to check whether that model is accurate or not. For this, we need to test algorithm. So what is the accuracy of the model we need to check. Next, what is the operation and optimization? So operation is how the system is working. Optimization, what is the accuracy? How much precision the system is working. Important Python libraries available to us are NumPy, which is very important, which stands for numerical Python. It provides an abundance of useful features for operations on matrices. Next, coming to the important library is Pandas, perfect tool for data wrangling. It is designed for quick and easy data manipulation, aggregation, and visualization. Next, scikit-learn, simple and efficient or data mining and data analysis built on NumPy and Matplotlib, open source. Next, Seaborn, focused on the visual of statistical models, which include that maps and depict the overall distribution. And next, Matplotlib. It enables you to make bar charts, scatter plots, line charts, histograms, pie charts, contour plots, pivot plots. What are the types of machine learning? We have supervised learning, reinforcement learning, and unsupervised learning. Supervised learning is here we are going to give the labels for the data. For example, we collect the label men face. Okay, input raw data is given, and from this model training is given. So here we take an algorithm. So here this algorithm is going to make use of this processing, and after that finally output will be produced. Model trained on, and finally it is going to give the input, take the input and produce the output. So it is checking whether it is a face learn. And unsupervised learning, you give input raw data, for example, fruits like apple, banana, mango. So here the output is unknown. No training data set is there. So interpretation will be performed, algorithm will be taken, and processing will be done. This is model training. And finally, the output will be either an apple or a banana or a mango. The final one will be model training. Next one, reinforcement learning. In the reinforcement learning, input raw data will be given, either apple or not apple. The environment here is producing, so here the reward, the state, the agent, and the selection of algorithm, best action, which environment model training will be performed here. And finally the output will be produced. So here when you take an input as a fruit, so here based on that the output will be produced. It is going to say that it is an apple. Here the important properties that are going to be identified by the model. Supervised learning is where you have input variables, for example x, and an output variable, for example y, and use an algorithm to learn the mapping function from the input to the output. So it is called supervised learning because the process of an algorithm learning is taught as a teacher supervising the learning process. In the supervised learning, we have training and testing, prediction. So historical data will be taken. From this random sampling will be performed. Here training data set will be done. Testing data set will be done. In the training data set, machine learning will be there and different statistical models. From there, prediction and testing. And finally, what is the outcome? Supervised learning. If you take the new data, a model will be built from that new data and finally the predicted outcome will be. Supervised learning algorithms that are more popular we using here are linear regression, logistic regression, decision tree, random forest, and naive Bayes classifier. So first let us see what is linear regression. Linear regression analysis is a powerful technique used for predicting the unknown value of a variable, that is dependent variable, from the known value of another variables, that is independent variable. So here a dependent variable is nothing but the variable to be predicted or explained in a regression mode. And an independent variable is nothing but the variable related to the dependent variable in a regression equation. So you can see the simple linear regression. It consists of dependent variable and independent variable. So how you write in the form of an equation y equal to a plus bx. Here what is y? Dependent variable. What is x? Independent variable. What is a? Y-intercept. And what is b? The slope of the line. Regression line. Linear regression analysis is a powerful technique used for predicting the unknown value of a variable, that is dependent variable, from the regression line. So here the regression line is simply a single line that best fits the data in terms of having the smallest overall distance from the line to the points. So here you can see in the xy axis in middle there is a line. So here we have that line is called a regression line, and the points which are fitted towards the line, you can see how the distribution of the points is being done. And you can see here a demo. Here we can see a real estate company use case. For example, a person, hi, I am John. I need some baseline for pricing my villas and independent houses. He need to have some help, that is baseline for pricing his villas and independent houses. So here the data set description will be done in the column. If you take, for example, CRIM, what does this describe? Per capita crime rate by town. Next, ZN, proportion of residential land zone for lots over 25,000 square feet. Next, Indus, proportion of non-retail business acres per town. Next, CAS, Charles River dummy variable. 1 if track bounds river or 0 otherwise. Next, NOx, nitric oxides concentration. It is parts per 10 million. Next, RM, average number of rooms per dwelling. Next, age, proportion of owner occupied units built prior to 1940. DIS, weighted distances to 5 Boston employment centers. RAD, index of accessibility to radial highways. Next, tax, full value property tax rate per $10,000. PT ratio, pupil teacher ratio by town. B is 1000. Here BK minus 0.63 square. Here where BK is nothing but the proportion of blacks by town. And L stat, percentage lower status of the population. And MEDV, median value of owner occupied homes in $1,000. So here we see the different steps like collecting the data, data wrangling, analyze data, train algorithm, test algorithm, and deploy. Model fitting. Fitting a model means that you are making your algorithm learn the relationship between predictors and outcome so that you can predict the future values of the outcome. So the best fitted model has a specific set of parameters which best defines the problem at hand. Here you can take the x-axis and y-axis. In the x-axis we have human population and the y-axis we have forest land. So here the forecast will be performed. Next, types of fitting. Machine learning algorithms first attempt to solve the problem of underfitting. That is, of taking a line that does not approximate the data well and making it to approximate the data better. So first you can see underfit. Next we can see appropriate and finally overfit. What is the need for logistic regression? Here, for example, if you take the polling, that is voting process, who will win? So here you can take the different axis or different votes that have been, what is the percentage or how many number of votes we have got. Here, the best line in linear regression is going below 0 and above 1. What is logistic regression? Logistic regression is a statistical method for analyzing a data set in which there are one or more independent variables that determine an outcome. Here the outcome is a binary class type. So the logistic regression curve is called a sigmoid curve, also known as S curve. Based on the threshold value set, we decide the output from the function. What is polynomial regression? When we have nonlinear data which cannot be predicted with a linear model, we switch to polynomial regression. Such a scenario is shown in the below graph. You can see there is some equation like equal to 3x square plus 4x square minus 5. So here we can see that. Now, what is a decision tree? A decision tree is a tree-like structure in which internal node represents test on an attribute. Here we can see each branch is representing the outcome of the test and each leaf node represents class label, that is the decision taken after computing all attributes. And next you can take see that a path from root to leaf represents the classification rules. Next, building a decision tree. Here you can see the outlook, how the atmosphere temperature is there. Sunny, for example. Uh, Here you can take overcast. You can take rain. So here, for example, in the rain, you can see what is the day 4, day 5, day 6, day 10, day 14, and what is the outlook, whether it is raining or not, humidity, high or normal, wind, whether it is weak or strong. How do you build a decision tree? Here you can see the first outlook we have taken, whether it is cloudy or it is sunny or it is overcast or rain. So sunny means again humidity will be get high or normal. And if you take the outlook here, we have rain. So here the rain is the outlook. So here that we need to check. How do you build a decision tree? Outlook is sunny, whether it is overcast or rain. Pure subset. Here you can see in the high the humidity wind. So you can see here in the outlook sunny, overcast, rain. Again in the sunny, humidity high or normal. And if the rain, it is windy, it is weak or strong. So when you make use of this decision tree building, you also should learn about humidity. That is Pause. Next, what is random forest? Random forest is an ensemble classifier made using many decision tree models. So, what are ensemble models? How is it better? So, what is naive Bayes? Random forest is an ensemble classifier made using many decision tree models. So, here in this diagram, we can see how the tree and the child relationship here is maintained. So, naive Bayes is a simple but surprisingly powerful algorithm for predictive modeling. So, here, so the classification technique is going to play a vital role. So what is Bayes' theorem? Important theorem is given a hypothesis H and evidence E. Bayes' theorem states that the relationship between the probability of the hypothesis before getting the evidence and the probability of the hypothesis after getting the evidence. PHIE. The formula is PHIE equal to P of E by H into PH by P of E. Next, you can see the Bayes theorem example. For example, how many kings are there? What is the probability of the king coming? For example, 4 by 52, it is 1 by 13. So here we are getting use of the probability for king, whether face is matching or not. So in this probability, I think all of you know P of A or B equal to P of A intersection B. Next, Bayes theorem example. What is Bayes theorem? Here we can see the conditional probability P of A or B. Here P of B intersection B by P of B. And coming to the reverse, P of B or A equal to P of B intersection A by P of A. So P of A intersection B is equal to P of A or B into P of that equal to P of B for A into P of A. That equal to P of A over A. So here we can see the formula as P of B or A into P of A by P of B. So Uh, proof of the Bayes theorem. Likelihood. How probable is the evidence given that our hypothesis is true? Prior. How probable was our hypothesis before observing the evidence? Posterior. How probable is our hypothesis given the Bayes theorem? Proof. Marginal. How probable is this? New. Under all possible hypotheses, whether it's an do. Next, classification steps. We have seen the table previously. In this classification steps, we take first to compare here in the classification steps, we have a table representing the day, outlook, humidity, wind, and play. So here in the frequency table, we need to divide into outlook as sunny, overcast, and rainy. In the play, we have yes or no. So that is going to be observed. And classification steps now you can see P of X Y is equal to here you can see the different formulas how we can calculate that. Okay, likelihood table for humidity. I already told you no confusion matrix should be built for this. What are the probability of yes or high, no or high, yes or weak, no or weak. Everything will be calculated in this fashion. So what are the classification steps? Suppose we have a day with the following values. Outlook rain equal to rain, humidity equal to high, internals. So the classification steps, what are the outlook, humidity, wind. Okay, what is the likelihood of yes on that day? You can see that P equal to P of outlook equal to range. Okay. What are the different classification steps? Our model predicts that there is a chance of 55%. So our model predicts that there is a 55% chance there will be game tomorrow. So industrial use case, if you take news categorization, the weather prediction, spam filtering. So unsupervised learning also should be learned by. Unsupervised learning is a Unsupervised learning is a type of machine learning algorithm used to draw inferences from data sets consisting of input data without any labeled response. So here we give the input raw data as apple, banana, and mango again. Here we got, okay. Unsupervised learning process flow. If you see, the training data is collection of information without any label. So here it will go to machine learning algorithm and predictions also play an important role. So next, what is clustering? Clustering is the process of dividing the data sets into groups consisting of similar data points. So here we can see that the similar objects based on the size, shape or color, they will be putting under one box, that is called clustering. That means the clustering is the process of dividing the data sets into groups consisting of similar data points. Next, why is clustering used? The goal of clustering is to determine the intrinsic programming.